Hello, welcome friends. Me Anila. The topic of my discussion is toughest numericals on sugars. But before this, don't forget to like and subscribe my channel and press bell icon. Friends, in this video, I will tell you how to solve toughest numericals on sugars. What are sugars? These are called carbohydrates made from carbon, hydrogen and oxygen. There are monomers called monosaccharides, glucose and fructose and galactose, and disaccharide, fructose, maltose and lactose, and polysaccharide, starch and glycogen, etc. So, in this video, I will tell you how we will solve the toughest numericals on sugars. Example number 1. Three solutions are made by dissolving 9 gram glucose, 17.1 gram of maltose and 17.1 gram of sucrose separately in 500 ml of water at 25 degrees centigrade. Which solution will exert the highest osmotic pressure? So we have three solutions. One solution contains 5 ml, 100 ml water and 9 gram glucose. Second solution contains 17.1 gram maltose and in 500 ml of water. And third solution contains 17.1 gram sucrose in 500 ml of water. The amount of water is same in the three solution. Temperature is also same in the three solution. Now we have to find which solution will exert the highest osmotic pressure. First of all, we will find moles of these solutions. For moles, we have to calculate first molecular weight. Now, molecular weight of glucose. C6H12O6. 6 is the number of carbon atom into 12 is the atomic weight of carbon plus 12 is the number of hydrogen atom into 1 is the atomic weight of hydrogen plus 6 is the number of oxygen atom into 16 is the atomic weight of oxygen. The molecular weight of glucose is calculated to be 180 gram per mole. Moles of glucose is equal to, we will place amount that is 9 gram divided by molecular weight of glucose 180 gram per mole. After solving, the moles of glucose are 0.05 moles. Now we have to calculate molecular weight of maltose. C12H22O11 is equal to 12 is the number of carbon atom into 12 is the atomic weight of carbon plus 22 is the number of hydrogen atoms into 1 is the atomic weight of hydrogen plus 11 is the number of oxygen atoms into 16 is the atomic weight of oxygen. The molecular weight of maltose is calculated to be 342 gram per mole. Now we will calculate moles of maltose amount divided by molecular weight of maltose 17.1 gram divided by 342 gram per mole. Answer is calculated to be 0.05 moles. Now it's time for sucrose. Molecular weight of sucrose. Sucrose has the same molecular formula as that of maltose, C12H22O11. So molecular weight of sucrose is also 342 gram per mole as that of maltose. Moles of sucrose is equal to amount divided by molecular weight 17.1 gram divided by 342 gram per mole. Moles of sucrose are calculated to be 0.05 moles. In three of these solutions, the number of moles of solute are same, that is 0.05 moles. Volume is given in 500 ml is equal to 0.5 liter. because 1000 ml is 1 liter and 500 ml is zero point 0.5 liter. Temperature is 25 degrees centigrade. We have to convert it into Kelvin. 25 degrees centigrade plus 273 is equal to 298 Kelvin. Here the constant R has the value 0.08201 atmosphere liter mole inverse Kelvin inverse. Now we know that PV is equal to nRT. P is the pressure, V is the volume, N is number of moles, R is constant, and capital T is temperature. And P is equal to nRT over V. Because glucose, maltose and sucrose has same number of moles and same conditions, so pressure is directly proportional to moles. So all of these exert similar osmotic pressure. That is because in solution 1 moles are 0.05 moles, solution second 0.05 moles, solution third 0.05 moles. When we will put these values in the formula, we will put 0.05 moles into R value into temperature divided by volume. We will place all values in the formula and the pressure is calculated to be 2.44 atmosphere. Because the number of moles are same for three solutions, and the other conditions are also same, that is value of R, temperature and volume are also same, so pressure is directly proportional to moles. So because three solutions have same moles, so the pressure would be same. Example number 2. 9 gram of glucose, maltose and sucrose are separately dissolved in 1 liter of water at 27 degrees centigrade. Which solution has highest osmotic pressure? So in this example also we have three solutions. One solution contains 9 gram glucose per liter of water. Second solution contains 9 gram maltose per liter water. Third solution contains 9 gram sucrose per liter water. Temperature is same in three of these solutions, 27 degrees centigrade. We have to find which solution is highest osmotic pressure. Solution. First we will calculate moles of glucose, maltose and sucrose. Moles of glucose is equal to amount divided by molecular weight, that is 9 gram divided by 180 gram per mole. As I have discussed earlier, the molecular weight of glucose is 180 gram per mole. So moles of glucose are calculated to be 0.05 moles. Moles of maltose is 9 gram divided by 342 gram per mole. We have calculated the molecular weight of maltose earlier. So moles of maltose is 0.026 moles. Moles of sucrose is equal to 9 gram divided by 342 gram per mole, that is molecular weight of sucrose, as I have discussed earlier. So moles of sucrose are 0.026 moles. Volume is given in liter, 1 liter, so we will not change the unit. Temperature is 27 degrees centigrade. We have to convert it into Kelvin. We will plus it with 273. It becomes 300 Kelvin. Constant R has a value 0.08201 atmosphere liter mole inverse Kelvin inverse. We know that P is equal to nRT over V. Now, moles of glucose are greater and moles of sucrose and maltose are less. Because other conditions are same, that is unit of R, temperature and volume are same, so pressure is directly proportional to number of moles. Since number of moles of glucose are greater, so pressure exerted by glucose solution is greater. And since maltose and sucrose have same number of moles, so they both exert less pressure. Here RT and V are same for three solutions, but moles of glucose are greater, so glucose exert the higher pressure. Since maltose and sucrose have same moles, so they both exert the similar pressure, that is sucrose is equal, pressure of sucrose is equal to pressure of maltose, and the pressure of glucose is higher. In this way, we can calculate the pressure of different sugars. Friends, if you have any question, you can ask me on comments. I can help you. Thanks.